Hello, welcome back to another flexible filament testing video. Slowly I'm building my TPU testing database for my Patreon supporters, and in this video I will have a direct comparison of BambuLab TPU95A HF versus Qidi TPU95A HF. And I bought these filaments myself. Earlier BambuLab sent me their TPU95A, but I noticed in the meantime that this material is discontinued by BambuLab. It is replaced by this one. Actually, according to specifications, huge difference in the maximal flow rate. Now what will be interesting in this video, that each of them will be printed on their own printers using the default settings in their own slicers. The Qidi will be printed on X-Max 3 and the BambuLab will be printed on X1 carbon. Now small disclaimer here, the X1 carbon has the hardened steel nozzle and it has a little bit weaker thermal conductivity. This means that the layer adhesion may be a little bit weaker compared to one if I would print with P1S, but I don't have that printer. And don't forget, this is not AMS compatible. Now the 95A means the hardness on shore A scale. But the hardness is actually the resistance of material to the penetration. But the elasticity and flexibility is something different. Now that's why I have my regular testing methods, where I also measure the elasticity directly with the filament too. The price is more or less very similar, but the BambuLab is available in more colors. These are information on the box, but anyway I will use the default settings in their slicers. But let's say the printing temperature between 220 and 240 degrees Celsius on BambuLab and 210 and 230 degrees Celsius on Qidi TPU filament. And here we have the information that the print speed is maximal up to 120 mm per second. So far the packaging is also similar, because this kind of packaging is good against the moisture, because don't forget, TPU filaments are very sensitive to moisture. Looks like the Qidi packaging is resealable, so don't forget, cut it above this sealing line. Oh, looks like the BambuLab is also resealable, so be careful, because I wanted to cut it here because this is bigger than this side, but actually if I cut it here, then I can reseal it. I will suggest to BambuLab that right here, don't open on this side. The BambuLab will be in gray color and the Qidi in black color, and again we have here those informations which already saw on the box. BambuLab arrives on the spool, which can be heated up to 90 degrees Celsius for the drying. And here we have the scale, so we can see how many grams we have approximately on the filament, and basically that's it. The packaging is good and they should be dry out of the box, but just in case I will dry them together on 60 degrees Celsius, maybe 2 or 3 hours. And I really like this function of this iBoss filament dryer rotating of the spool, so they will be dried more equally. After 2.5 hours of drying, it's time to start with the printing, and actually I noticed this rotation motor struggles a little bit when there are two spools inside, and the printing will be from the open air. Now I have to disable the camera because there will be too much swearing, because I have to place these spools on the back side of these printers. In the meantime the filaments are changed. Let's check the slicer. This is the Bambu Studio and these are the test objects which I'm regularly using in these TPU testing videos. Let's see the default settings. 230 on the nozzle, 45 on text tool bed, and 12 cubic millimeters per second will be the maximal flow rate. And 20 volts, so these are solid inside. This is the Qidi slicer. The same test objects, and unfortunately there is no Qidi TPU filament in their list, so I'm using here the generic TPU, and the default settings will be 230 on the nozzle and 45 on the bed. And very important, I change here 10 cubic millimeters per second. I calculated this from 120 millimeters per second speed. Here you can see the equation. It is so scary watching this TPU printing so fast. Oh, it's not completely perfect. There is one small problem with that one object, and I'm not sure should I cancel the printing or maybe skip that one object, but I will leave it printing so far. And let's watch the progress with the Qidi. Here everything looks fine. The progress is smaller, so it's printing slower, but everything is okay so far. But it looks like it was self-corrected, but I can see much more stringing on this printing compared to this one here. Or maybe just we cannot see it on the black color. I will analyze it when it's finished. Last objects for the layer adhesion test on the BambuLab, and last objects on the Qidi printer. On time-lapse, I analyzed the problem on the BambuLab printing, and this is the first layer. There is no extra material on that object, but there is some oozing material on the nozzle. And this is the second layer. That material from the nozzle stick to this object, but on the rest of the time-lapse we can see that the printing was next to it, so it doesn't cause any further problem and the printing was finished successfully. I just removed the build plate from the printer, and I can clearly see that there is more stringing on the BambuLab printing and less stringing on Qidi printing. And now let's try to remove the objects. Okay. Texture PI sheet in both cases. I'll need one more testing for myself. I subbed the filament, so the BambuLab is now inserted into Qidi, and the Qidi filament is in BambuLab printer. And I want to print just small string tests, and I will limit the flow rate to 10 cubic millimeters per second. This is BambuLab printer, Qidi filament. And this is Qidi printer, BambuLab filament. Again, I just take out the build plates from the printer, and now let's analyze the objects. So this one was printed on BambuLab with the Qidi TPU filament, and absolutely no string on this one. And this one was printed on Qidi printer using BambuLab TPU filament. As you can see, not too much, but noticeable more stringing compared to the previous one. So it is not the printer, but the filament. And side by side. And just one more quick test. I'm printing with both filaments on the same printer. This is Prusa Mark IV, which I usually use for the TPU filaments. And here you can see side by side. I will analyze these objects later, but so far it looks like just a little bit more stringing on the left side on the BambuLab printing. And after the printing, only on this one spot actually I can see a little bit more stringing, but otherwise these are quite equal string test prints from each side. And now I can move to the mechanical testing. I already have several tests in the progress. These are some PLA materials from BambuLab, and these are some glass and carbon fiber filaments. For the feeling, the elasticity is very similar between these two filaments, but let's see if I can measure some difference. First, I want to measure the flexibility of the filament itself, and I have this 20 centimeter distancer. The load is exactly 0.5 kilograms. Eight millimeters. 7. The Tensile pulling test with horizontally printed objects, and also I try to measure here some prolongation in percentage. The average load is 7.8 kilograms was the break load, and this is now the Qidi filament. And very similar values I got here. And this is how they look like, very stringy break on the BambuLab filament. And now the layer adhesion test with the vertically printed objects, 22.8, which is acceptable for TPU filament, but Qidi was stronger, 31 kilograms. And here you can see side by side, very nice to see the prolongation too, not just break. And this is how they look like after this test. And now the ring test, and the first one is the one which will be compressed and where we have some bending stress too. And here I can see them side by side, and first I'm measuring the initial deformation. This is the deformation after 1 minute. And the deformation after 2 minutes. This is a second ring test which will be pulled, so we have some bending and pulling stress. The load is 1.25 kilograms. And here I am measuring the initial deformation. The default size is 50 millimeters. And after 2 minutes. And after this test I cannot see any permanent deformation on these test objects. And now the washer test with these M6 bolts. The pitch is 1 millimeter. And now we have exactly 3 rotations, that is a 3 mm compression. And I will measure the maximal torque. And here you can see with bamboo filament 2.3 Newton meters was the maximal torque. And this is now Qidi filament, 3.2 Newton meters was the maximal torque in this case. And this is how they look like, and now we'll wait exactly 1 day. And next day I am measuring the untightening torque. This is the bamboo filament. The untightening torque is 0.9 Newton meters, and on Qidi filament 1.5 Newton meters. And after half hours I'm measuring their deformation, which is almost permanent deformation, and I will show you the numbers in the results part. The friction test on the glass, and these legs are 3D printed, and the total weight will be 3.5 kilograms, and I will measure the pulling force in kilograms, and theoretically the softer filament should have bigger friction here.
0.70 something, 0.76, 0.77, 0.74, 0.87, 0.91, 0.90, 0.87.
Again, a small surprise. I was expecting a little bit bigger friction with BambuLab filaments compared to the Qidi. This is Shore A durometer. The 95A in the name of the filament is the hardness of the material itself, which I cannot really measure with this equipment, but I can measure the hardness of 3D printed objects, which is properly different. And I will do the measuring on the top layer. Bamboo filament 95, 94.5 and 94. Qidi 97, 95.5, 96. This means BambuLab is softer compared to the Qidi TPU. The creep test, the thickness of these test objects is 2 volts and 1.25 kg is the load, and a little bit more elasticity with the BambuLab filament. And this is day 5 and still more deformation on the BambuLab filament. And I can see slightly more permanent deformation on this material. And now the temperature test in the oven with the M10 nut as a small load. And I want to record the temperature of the first deformation, which is a little bit hard with the flexible filaments, but this is the comparison video and I'll try to get some numbers. This is a time-lapse or speed-up video, 25 times, and it was a little bit hard to notice exactly the start of the deformation, but I analyzed this picture by picture, and here you can see the numbers. Okay, I think I can stop the experiment now. For the filling they are very similar. And now after 1 minute I can already touch them. As you can see, similar deformation in both cases. And it's time to summarize the results, and this Excel table you can download from mytechfun.com website, but the data also goes to that summary table for my Patreon supporters. Here you can see some print settings, but let's start with the creeping. And even here I can see more deformation on BambuLab filament compared to the Qidi, but this is about creeping, so the difference between 2 days can be seen on this table or on this graph. And we can see that basically after second day it stopped with the deforming, and after this the results were similar. On the tensile or pulling test, there is no big difference here, and this is the prolongation, actually the new length before the break, and it was also very similar. Now on layer adhesion, here we can see some bigger difference, 31 kilograms. This is really good, not only for TPU filaments, but also it was good to see in both cases some prolongation before the break. And this is that ring test with the compression, and here smaller values means less deformation, but it doesn't mean that this is better, depends what you need. So maybe if you need more elasticity, this is better for you. And similar results with less deformation on Qidi filament. And then that washer test, here again we can see some bigger differences, so I needed more torque to compress 3 mm this washer, but also the untightening torque was bigger too. But for me it is very important the ratio of these two numbers, and in this case it was better with the Qidi filament. On temperature test, well, it was really hard to see when it starts with the deforming, but here you can see a screenshot, so definitely just a slightly better was the Qidi filament in this test. On the friction test, this is really surprising results. I'm not sure why, but actually the bigger friction I got with the harder material, it was with the Qidi. This is the flexibility test with the raw filament, and here you can see a little bit more deformation with the BambuLab compared to the Qidi, so this means it is more flexible under this same load. And at the end I measured the hardness of 3D printed object, and slightly harder is the Qidi TPU filament compared to the BambuLab, but in both cases they were around 95 on Shore scale. And now my final thoughts. Well, I think these two filaments are more or less very similar. I cannot tell that one is better than the other. Depend on your needs actually. If you need more elastic filament, in that case the BambuLab is better for you between these two. If you need flexible but more rigid, in that case Qidi. Maybe two properties I could mention here because they are important for me, and that's the layer adhesion, and the Qidi was better in this case. And the second is that I experienced a little bit more stringy when I printed with the BambuLab TPU filament, and I believe that reason for this is that higher viscosity on these temperatures because it can be printed on higher speeds too. Now, unfortunately, I have to mention again, if you like this kind of videos and you would like to get a notification, I have in the progress very similar videos, in that case definitely you should click that notification bell button too, otherwise in most cases the notification is not sent. And how do I know this? Well, it is very simple. If I have almost 47,000 subscribers and only 3,000 to 4,000 views per video, and half of those are not even subscribed, I know that in most cases the notification about new upload is not sent. I don't know about the reason. Actually, I asked the YouTube support about this, and I think they're highly trained to get rid of this kind of questions. They just give me some untouchable statistics and numbers and similar, and I didn't dare to bother them too much because I may disappear from YouTube like 3D Printing General. Have you noticed? He's not even on YouTube anymore. You can find him on Twitter. Let's give him some support there. Okay, so thank you for watching and happy printing.